3-light plug-in testers are often viewed with skepticism by electricians and electrical engineers. The reason for this skepticism stems from the inherent limitations of these devices in accurately diagnosing complex electrical problems, particularly a faulty neutral connection. These testers, often called circuit testers, rely on a simple arrangement of 3 neon or LED lights to indicate the presence of voltage between the hot, neutral, and ground wires at an electrical outlet. By observing the combination of lights that illuminate, the user attempts to infer the wiring condition of the outlet. However, this method is prone to misinterpretation and can provide misleading results due to several factors. One significant limitation is that these testers only indicate the presence or absence of voltage, but not the quality or impedance of the connections. A faulty neutral, for example, might still allow enough voltage to be present for the tester to indicate a correct wiring configuration, even though the neutral conductor is compromised. This can lead to a false sense of security and potentially dangerous situations. Another issue is that 3-light testers are susceptible to being influenced by upstream wiring problems or voltage imbalances in the electrical system. For example, if there is a shared neutral conductor serving multiple circuits and one of those circuits has a significant load imbalance, it can cause a voltage drop or rise on the neutral conductor. This voltage fluctuation can then affect the readings of the 3-light tester, making it difficult to determine the true condition of the outlet being tested. Furthermore, these testers typically do not provide any information about the magnitude of voltage or current present in the circuit. This makes it impossible to assess the overall health of the electrical system or to identify potential overload conditions. A high-resistance neutral connection, for instance, might not be detectable by a 3-light tester, but it can lead to excessive heat build-up and potentially cause a fire. Because of these limitations, qualified electricians rely on more sophisticated testing equipment and techniques to diagnose electrical problems. These tools include digital multimeters, which can measure voltage, current, resistance, and continuity with high accuracy. They also use clamp-on ammeters to measure the current flowing through conductors without having to interrupt the circuit. Insulation resistance testers, also known as megometers or megas, are used to assess the integrity of insulation on electrical wiring, helping to identify potential short circuits or ground faults. Additionally, electricians employ circuit tracers to locate specific wires or circuits within a building's electrical system, making it easier to troubleshoot wiring problems. To properly diagnose a faulty neutral, an electrician would typically perform several tests. Firstly, they would use a digital multimeter to measure the voltage between the hot and neutral conductors, the hot and ground conductors, and the neutral and ground conductors. In a properly wired circuit, the voltage between the hot and neutral should be approximately 120 volts. In a standard residential circuit, the voltage between the hot and ground should also be approximately 120 volts, and the voltage between the neutral and ground should be very close to 0 volts. A significant voltage reading between the neutral and ground conductors can indicate a problem with the neutral connection. Secondly, the electrician would perform a load test to assess the neutral's ability to carry current under load. This involves plugging in a known load, such as a lamp or appliance, and then measuring the voltage drop across the neutral conductor. A high voltage drop indicates a high resistance connection, which can lead to overheating and other problems. Thirdly, the electrician would visually inspect the neutral connections at the outlet, the electrical panel, and any other accessible points in the circuit. They would look for signs of corrosion, loose connections, or damaged wiring. If any issues are found, they would be corrected immediately. The National Electrical Code, NEC, provides specific guidelines for the installation and maintenance of electrical systems, including neutral conductors. NEC Section 250.24 requires that the grounded conductor, typically the neutral, be connected to a grounding electrode system at the service entrance. This ensures that the electrical system is properly grounded and that any fault current will flow safely back to the source. NEC Section 300.13 B requires that the continuity of the neutral conductor be maintained throughout the circuit, even when devices are removed or replaced. This prevents the neutral from being inadvertently disconnected, which can create a dangerous floating neutral condition. In addition to the NEC requirements, local electrical codes and regulations may also apply. It is important to consult with a qualified electrician to ensure that all electrical work is performed in accordance with applicable codes. Here's a more in-depth look at why these 3 light testers are often considered unreliable and the proper methods for identifying a faulty neutral. Firstly, the limitations of 3 light testers needs to be mentioned. These testers are designed to indicate basic wiring configurations such as correct wiring, open ground, open neutral, hot/ground reverse, and hot/neutral reverse. They achieve this by illuminating different combinations of 3 lights based on the voltage present between the hot, neutral, and ground wires. However, they cannot detect many subtle but critical wiring problems, including high resistance connections, shared neutrals with excessive current, and small voltage differences. Secondly, the testers often provide misleading results. A common scenario is a false positive where the tester indicates correct wiring even though a problem exists. For example, a high resistance neutral connection might still allow enough voltage to be present for the tester to show a correct wiring configuration, while simultaneously causing voltage drops and potential overheating. Conversely, a false negative can occur where the tester indicates a wiring fault when none exists. This can happen if there is slight voltage imbalance in the system, which can be caused by various factors such as unbalanced loads or nearby electrical equipment. Thirdly, the testers lack diagnostic capabilities. They provide no quantitative data about the electrical parameters of the circuit. They cannot measure voltage levels, current flow, impedance, or other important electrical characteristics. This makes it impossible to assess the overall health of the circuit or to diagnose complex wiring problems. In contrast, professional electricians use a variety of tools and techniques to accurately identify a faulty neutral. Firstly, they use digital multimeters or DMM, which are versatile instruments that can measure voltage, current, resistance, and continuity. When testing for a faulty neutral, an electrician would use a DMM to measure the voltage between the neutral and ground wires. In a properly wired circuit, this voltage should be very close to 0 volts. A reading of more than a few volts indicates a potential problem with the neutral connection. They also use clamp-on ammeters. These devices measure the current flowing through a conductor without having to interrupt the circuit. An electrician can use a clamp-on ammeter to measure the current flowing through the neutral conductor. In a balanced circuit, the neutral current should be relatively low. A high neutral current indicates an imbalance in the circuit, which can be caused by a faulty neutral connection. Also, they use insulation resistance testers or megameters mentioned earlier. These instruments apply a high voltage to the wiring and measure the resistance of the insulation. This can help to identify damaged or deteriorated insulation, which can contribute to neutral problems. Besides specific tools, electricians use a systematic approach to diagnose neutral problems. Firstly, a visual inspection is done. The electrician will visually inspect the wiring, connections, and devices for any signs of damage, corrosion, or loose connections. This includes checking the connections at the outlets, switches, light fixtures, and electrical panel. After the visual inspection, voltage testing is performed. The electrician will use a DMM to measure the voltage at various points in the circuit, including the outlets, switches, light fixtures, and electrical panel. This helps to identify voltage drops or imbalances that may indicate a neutral problem. After voltage testing, load testing is done. The electrician will apply a load to the circuit, such as a lamp or appliance, and then measure the voltage drop across the neutral conductor. High voltage drop indicates a high resistant connection, which can lead to overheating and other problems. The NEC provides specific guidelines for neutral conductors to ensure safety and reliability. NEC Section 250.4 A5 states that the neutral conductor must be grounded at the service entrance and at other points as required by the code. This ensures that the electrical system is properly grounded and that any fault current will flow safely back to the source. NEC Section 300.13 B requires that the continuity of the neutral conductor be maintained throughout the circuit. This means that the neutral conductor must not be broken or interrupted by any device or connection. NEC Section 310.15 provides guidelines for sizing neutral conductors based on the expected load. The neutral conductor must be sized to carry the maximum unbalanced load in the circuit. In summary, while 3-light testers can provide a quick and easy way to check basic wiring configurations, they are not a reliable tool for diagnosing faulty neutrals. Electricians use more sophisticated tools and techniques to accurately identify and repair neutral problems. It is important to consult with a qualified electrician if you suspect a faulty neutral in your electrical system. Here are some additional points to consider. Firstly, the impact of shared neutrals must be considered. In some older electrical systems, multiple circuits may share a common neutral conductor. This can create problems if the loads on the circuits are not balanced, as the neutral conductor may become overloaded. 3-light testers are not capable of detecting overloaded shared neutrals. Secondly, the effect of harmonics must be considered. Harmonics are distortion of the voltage and current waveforms that can be caused by electronic devices such as computers, fluorescent lights, and variable speed drives. Harmonics can cause excessive current to flow in the neutral conductor, even if the loads on the circuits are balanced. 3-light testers are not sensitive to harmonics and cannot detect this problem. Thirdly, the importance of regular inspections must be kept in mind. Electrical systems should be inspected regularly by a qualified electrician to identify potential problems before they become serious. This includes checking the wiring, connections, and devices for any signs of damage, corrosion, or loose connections. Furthermore, consider these additional factors that contribute to the unreliability of 3-light testers in detecting faulty neutrals. Firstly, the tester's reliance on voltage presence. 3-light testers primarily detect the presence of voltage between the hot, neutral, and ground wires. A faulty neutral might still allow sufficient voltage to be present for the tester to indicate a correct wiring configuration, even if the neutral connection is compromised. This can lead to a false sense of security, as the underlying problem remains undetected. Secondly, the inability to detect high resistance. A common issue with neutral connections is high resistance due to corrosion, loose connections, or damaged wiring. This high resistance can impede the flow of current, causing voltage drops and potential overheating. 3-light testers cannot detect high resistance connections, as they only indicate whether voltage is present, not the quality of the connection. Thirdly, the susceptibility to external factors. The readings of 3-light testers can be influenced by various external factors, such as voltage fluctuations, unbalanced loads, and nearby electrical equipment. These factors can cause the tester to give misleading results, making it difficult to determine the true condition of the circuit. Additionally, here are some of the advanced diagnostic techniques that qualified electricians employ to pinpoint neutral issues with accuracy. Firstly, time domain reflectometry, or TDR. TDR is a technique used to locate faults in cables and wires. It sends a pulse of energy down the conductor and measures the reflections that occur due to impedance changes. This can help to identify the location of a high resistance connection or break in the neutral conductor. Secondly, infrared thermography can be used to detect hotspots in electrical panels, outlets, and wiring. A faulty neutral connection can cause excessive heat buildup, which can be easily identified with an infrared camera. Thirdly, advanced power quality analyzers are used. These devices can measure various electrical parameters such as voltage, current, harmonics, and power factor. This can help to identify imbalances and distortions in the electrical system that may be caused by a faulty neutral. Moreover, consider the crucial safety implications of relying on 3-light testers for neutral fault detection. A faulty neutral can create a dangerous situation, as it can cause voltage to appear on metal parts of appliances and equipment. This can lead to electric shock if someone comes into contact with the energized metal. 3-light testers are not reliable enough to detect these situations, putting people at risk. Here is a more detailed look at the role of the NEC in ensuring safe and reliable neutral connections. NEC Section 250.24 C specifies the requirements for grounding the neutral conductor at the service entrance. This includes the size and type of grounding electrode conductor, as well as the method of connection to the grounding electrode system. NEC Section 250.28 provides requirements for bonding the neutral conductor to the equipment grounding system. This ensures that any fault current will flow safely back to the source, minimizing the risk of electric shock. NEC Section 310.15 B3 addresses the sizing of neutral conductors in multi-wire branch circuits. It specifies that the neutral conductor must be sized to carry the maximum unbalanced load in the circuit. Therefore, relying solely on a 3-light tester to assess the integrity of a neutral connection is not advisable. While these testers can indicate basic wiring configurations, they lack the sophistication to detect subtle but potentially dangerous neutral faults. It is always best to consult with a qualified electrician who can use advanced tools and techniques to accurately diagnose and repair any electrical problems. Remember that electrical safety should always be a top priority, and taking shortcuts or relying on unreliable methods can have serious consequences.